the greatest common factor. So we look at each term and say, what do we have in common? In fact, what's the greatest thing in common?
2x.
Very good. We have a 2 in common, but also each term has at least x squared. Is everybody comfortable with that? Because that was kind of what we struggled with a little bit yesterday. So we pull out 2x squared. Now don't forget to write on the outside what you pulled out. Now we're going to go back, divide each term by 2x squared and see what's left. Now there's a lot of common errors in this one, and I'm urging you not to make them. 2x squared divided by 2x squared is a what? 1. So this term became a 1. You've got to write the 1's in there. If you didn't write a 1, it would be 0. And that's not correct. Okay. Moving on, next piece. -4. Now if you have to look at it in pieces, you're going to be okay. Let's do that. -4 divided by 2. It's right, you're right. It's -2. Is everybody comfortable with that minus sign there? It's got to be there. If it was plus, that plus sign's got to be there. There's still 2 terms here. All right, and then x cubed divided by x squared. X, very good. So we have an x left. And then you look from here. You can always check your work. That's my answer, but if I took that and multiplied it back through, would I end up back at my beginning answer? So let's look. 2x squared times 1. 2x squared. 2x squared times -2x is -4x cubed. So we have done this correctly. Okay, very good. So I'm going to actually just do a lot of problems off the worksheet today. So you'll be able to get a lot done, hopefully, from my examples. I'm not doing any that aren't from the worksheet. Today we're going to see some advanced stuff. We're going to really have to be careful, use our brains, and check our work. So I even was thinking about a lot of these. I'm like, oh wow, that one's kind of hard. Let's think about this for a minute. All right, so we're doing number 4. It says simplify each product. So product means multiplication. So we're multiplying. Let's go through number 4 together. You guys still talk me through it. We need to do what here? What's the word? Distribute. Very good. So we're going to multiply this to all of this. So we're going to double distribute. -b squared times b. Very good. -b cubed. Questions on that? -b squared times -10. Very good. Very good. +10b squared. Okay, any questions? Don't feel dumb asking them. Today is the day to make sure we're all good. Because tomorrow is the big, big day. All right, any questions? Okay, we're all good. Let's go on to the next problem. Let's do number 7 together. 4t times t squared minus 6t plus 2. Once again, what's the mathematical word for what we're actually doing here? Distributing. And in this one, we're actually triple distributing since there's 3 terms. 4t times t squared is 4t what? 4t cubed. You're awesome. 4t times -6t.
24t squared.
Very good. And I like that I heard -24t squared. Very good. -24t squared. Awesome. And then 4t times +2. Very good. Positive, so plus 8t's. Now look, is it in standard form? Highest degree, next highest degree, next highest degree. All like terms are combined. Nothing here is like, so we're done. Very good. So guess what, guys? If we were here and we factored it, guess what? We're going to end back up right here. So once again, understand multiplication and factoring are opposites of each other. All right, let's do another one. Number 15. 11w times w squared plus 2w plus 6. I'm going to ask you once again, mathematically, what are we doing? Distributing. And what is it? What kind? Is it single distribute, double distribute, triple distribute? Awesome. So 11w times w squared is 11w cubed. You're awesome. 11w times 2w. Good, and it's positive, very good. 22w, I like that you didn't forget the squared part. That would be a big error there. And then 11w times positive 66 w's, very good. And from there, all like terms are combined, it's in standard form. So once again, if we factored that, we would end up back up here. We don't need to factor it though. We already know what it is when it's factored. All right, awesome. All right, so do 1 through 15. I'll give you a second to do those, and then we'll move on to GCF. Awesome it is. Okay, So I'm going to do number 17. Now read the directions. It says, find the GCF of the terms of each polynomial. Now yesterday it asked us to factor out the GCF. Today we're just finding, for this piece, we're just finding the greatest common factor of the terms. So we don't have to go all the way, we just have to find the greatest common factor. The only problem is I always go through and just do it completely because then it's easy for me to see if my greatest common factor is right. So I kind of debated on how to, like if I should just do one way or another, but I think I'm going to do it this way. Okay, so once again, let's look at number 17. So we have 6w cubed minus 14w. All right, so let's think about this in pieces. What do they both divide by? 6 and 14. 2. Can you think of anything greater? No? Right? 2 is the greatest thing. So we're going to pull out a 2. And then also, we can't forget, in each term, what is there? At least a w. This one has a w, this one has a w cubed. So we're pulling out a w as well. Now, I'm going to just go all the way, because to me, it's easy to check my work if I just have it all. But really, if you know for sure that's the GCF, you can stop there. I just want to make sure. So this would be 3w squared, and then minus 7. So then I look at my inside, and then nothing else came out, so I know my GCF was right. So we could have stopped there, but it's just a way of checking, obviously. Now that it's smaller, you can tell, okay, yeah, nothing would come out more, so I've done this right. So my GCF was 2w on number 17. Any questions on that? Okay, let's do another one, because there are some tricky ones here. Find the GCF of number 20. Negative 18 q to the third power minus 6q squared. Okay, this one's pretty obvious. What's in common in each term with our numbers? A 6. Good. We'll pull out a 6. And what else? Good. And I like that you said, oh, I have a negative in front, so we better be pulling out a negative with it. You're absolutely right. And then, what else is in common? Very good. That's a really fancy q. Sorry. That is a q, but yeah, q squared. There's at least q squared in q to the third, and there's a q squared. So we're pulling out 6q squared. Negative 6q squared. And that is the GCF. So I'm done there. Now, because it says find the GCF, I'm done. If it said factor out the GCF or factor, you'd keep going. Does that make sense? So I'm going to stop there. Is everybody okay with that? If I needed to check it, I could keep going. But this one I know for a sure fact, I'm good. All right, number 30. 12j to the 8th plus 30j to the 4th minus 6j cubed. Out of our numbers, what's in common? Very good. They each have a 6, and then what else? Good. The smallest one is j to the third. This one has a j to the third. This one at least has a j to the third, and this one at least has a j to the third. So we pull out 6j to the third. If you needed to check it, divide each term by that, and then look at your inside and see if there's anything more you could have pulled out. Very good. All right, so do 16 through 30. So, okay, number 31. Starting out really basic here. 12x minus 9. We're factoring out the GC. We're factoring the polynomial. And what we do when factoring is we factor out the greatest common factor. What's in common here? Does this one have an x? No, nice try though. Nice try. This 6, 9 doesn't divide by 6, but nice try. Good, they both divide by 3. All right, so we're pulling out a 3. Whatever you pull out, you write on the outside, divide each term by 3 to see what's left. In our first term, there's a 4x left. And then negative 9 divided by 3 is negative 3. Now you can circle your answer and say, okay, do I have anything more I should have pulled out? 4x and negative 3? Nope. So we're good. That is factored. Okay, another one. Number 46. X to the 6th minus x to the 4th plus x squared. What's in common in all three terms? Very good. The least greatest thing in common is an x squared. So if we pull out an x squared, we divide each term by x squared and see what's left in each term. So right here, x to the 6th divided by x squared. Good, x to the 4th. And the next term, negative x to the 4th divided by x squared. So it's going to be negative. Good, negative x squared. You're absolutely right. And then it's a positive, so it's going to be plus And then x squared divided by x squared is 1. I like that you said 1. Now you write the 1 in there. If you didn't, you'd be putting a 0, which isn't true. Very good. Couple more. Number 34. Negative 20, w squared plus 16w. What's the GCF? 4 and what else? Very good. And a w. And I like that you said, well, we have a negative in front, so we always factor out a negative. So then inside, divide each term by negative 4w. Don't forget that they each had a w in this problem in particular. So positive 5 and then what? Very good, w. And then it is minus, right? Because a positive divided by a negative is a negative. So minus 4, and then w divided by w is a 1. So 4 times 1 is just 4. Right? Okay. 37. 12n cubed minus 36n plus 18. What do we have in each term that's in common? The greatest thing. Very good. They all divide by 6. Can I pull out an n? Nope, the 18 doesn't have an n. So we're only pulling out a 6. Divide each term by 6. So we're going to have 2n cubed in our first term. And then minus 6n squared. And then plus 3. Very good. So plus 3. And then you would check, do all of those divide by something more? Nope. 2 and 3 don't have any common factors. So we're done. Okay, this one. 300. D squared minus 175d. Okay, there is a 25 in common. Very good. And what else? A d. So divide each term by what you pulled out. 25d. So 300. Okay, yep, you're right. In our first term, we have a 12d. And then in our second term, yep, very good, a negative 7. The d's divide out and are gone. So we'd be here. Good. Okay, looking good out there. So now do 31 through 48. Okay, so understand something. On the end of level test and on an ACT, there are only a certain number of questions. On the end of level test, you'll each answer about 40 questions. And every single problem is not going to just simply say, multiply the polynomials. Every single problem will be multiple problems within one problem because it's testing your knowledge on everything you've learned in a year and they only have 40 problems to do it. So something like this is very valid and it's not hard. You just have to know what you're doing. So it takes a little bit higher order thinking. That's same with the ACT. Every question will test multiple things, okay? So everybody, let's read this through and let's think critically for a second. So guys, just really focus with me on this one. If anything you get out of today, this is probably one of the most important things, okay? So it says, the figures below are squares. So what do we know about squares? They have the exact same length of sides, right? All the way around. Okay. So the figures below are squares. Find an expression for the area of each shaded region and write your answer in standard form. Okay, so it's testing our knowledge on, do you know how to find the area of a square, first of all? Well, area of a square or rectangle is equal to length times width, right? Now, it wants to know what's the area of the shaded region. So my shaded region is the green region. So let's think about this, guys. If this white box wasn't here, let's take that white box and throw it off. Couldn't we find the area of that, all of that really easily? Length times width. So to find the area of the green thing, ignoring the white box, wouldn't we just do x plus 2 times x plus 2? Length times width, right? Okay, let's just do that. We're ignoring the white box for a minute, pretending it's not there. So let's distribute. We're going to have x squared plus 2x plus 2x and then plus 4. Combine my terms, so the area of all of it without the white box is x squared plus 4x plus 4. Now, does everybody understand that? But that is not, we're not completely done. Okay? Yes, that is the area of the whole thing. Now, don't we have this white box that we need to take and subtract off? Yeah? Does it make sense of why we need to subtract it off? Okay, so can we find the area of this piece now? We know the area of that piece is length times width. So we're doing x minus 1 times x minus 1. So let's find the area of that little piece. Double distribute. We have x squared minus 1x minus 1x plus 1. Combine like terms. X squared minus 2x's plus 1. Okay, so now we know the area of that small piece. We need to take the area of the whole thing, the big thing, and subtract off the area of that piece so that we know the area of all of it with that piece taken out. So we'll take x squared plus 4x plus 4, and then we'll subtract off. Now, see what they're testing? They tested that you know how to find area. You had to be able to multiply a polynomial correctly, and now you have to be able to subtract a polynomial correctly. What do we know with subtraction? We have to put it in parentheses, right? So we're subtracting off this piece. Minus x squared minus 2x plus 1. So does everybody remember that with subtraction, since we're subtracting all of that, it has to be in parentheses? So they're testing that you can multiply a polynomial. They're testing that you can find area. And they're testing you can subtract a polynomial correctly. This is really, depth of knowledge-wise, this is what you're going to see almost every single problem. And you can do it, okay? So that's why we practice these things. Okay, let's do it. We know that's like having a negative 1 right there. So let's distribute it through. That's negative x squared. Negative 1 times negative 2x is positive 2x. Negative 1 times positive 1. Negative 1, right? And then we combine like terms. So we just still have x squared plus 4x plus 4. And we combine like terms here. So x squared minus x squared is gone. 4x plus 2x is 6x's. Positive 4 minus 1 is plus 3. And we're done. So all that work just to get that answer. And you can do it, guys. I'm telling you, you are all smart enough to do this, okay? So, and I'm going to do number 17. Exact same thing, but in words. Here we go. A square brown tart has a square green patch in the corner. The side length of the tart is 8x plus 8. And the side length of the patch is x. What is the area of the brown part of the tart? So I'm doing number 17. So I'm going to draw my own picture. A square brown tart. So I'm drawing a square. We have a square brown tart. And it has a green patch in the corner. So I'm going to draw another square patch in the corner. And it says the side length of the tart is x plus 8. So this is x plus 8. And if it's a square, then this is also x plus 8. And then it says the side length of the patch is x. So here's my patch. This is x. This must be x. Now we're going to find the area of each piece. And it says, what's the area of the tart? So we're trying to find the area of this piece. So it's the same problem. We've got to find the area of the whole thing and subtract off that piece right there. So we're doing x plus 8 times x plus 8. And then we're going to find that. So we have x squared plus 8x. Plus 8x, I'm double distributing in my head here, plus 64. So we have x squared plus 16x plus 64. And then we're subtracting off the area of this little piece because that is not a part of it. That's taking up space. So then we're going to subtract off that area, which is x times x, which is x squared. So minus, in parentheses, x squared. All right, so with this one, we just have minus x squared, that's like negative 1, distribute it through, so negative x squared. We combine like terms, x squared minus x squared is gone. We have 16x plus 64, so that's our answer. The area of the tart, ding ding ding, is 16x plus 64. Alright, now I want you doing problems 13 through 18. I need you to skip to those. Like I said, if you get anything out of today's worksheet, I want it to be that. So everybody do 13 through 18. If you'll do that and finish it, I'll consider possibly not making you do the ones above it. But they're good practice. So if you've already done them, that's great. Okay, so 13 through 18, that's what I want you working on right now. Ready, set, go.